Oni will have so much here because Oni is polymer, polyester. Yes, correct. I'm polyester. But actually, I made from PET before. So your water bottle Oni before? Yes, for sure. I'm recycle one. Okay. What is polymers? Polymer actually a large molecule, but built up from many smaller molecules. That small molecule is called monomers, and it's repeat the pattern. So polymer always have pattern. Okay, so the patterns from the monomers will create a large molecule that called polymers. It's organic molecule because always contain carbon and hydrogen. Okay. Polymerization reaction, there is two way of polymerization, creating polymer from the monomers. The first one is called addition. In the addition polymerization, there is should be double bond. Okay, the monomer should have double in addition polymerization. While in the condensation, it can be have more than one monomer. Usually, it has two type of monomer. Sometimes it's only have one, like for example, if you know starch is condensation. Actually, it's made by condensation. Okay. In addition, always only one type of monomers, but in condensation, it can be made from two type of monomers. And remember, in addition, it should the monomer have double bond because when it's make the polymerization happen, it will break the double bond. Okay, so the process in addition polymerization is breaking the double bond, while the condensation reaction is like the esterification before that we talked about. It's elimination of small molecule, usually water or some time of halogens acid, nitrogen halogen, like HCl, HI, HF, and so on. Okay, and creating a specific bond. In the polymerization, there is no specific bond in addition, but in condensation, there is specific bond, usually ester bond, or amide. While you only need to learn two of it, ester and amide. While in bio, you cannot call it amide actually, but amine group. But in chemistry, you call it amide. It's okay. It's no different at all actually. Okay. The product of addition molecule polymerization is only the polymer itself, while in the condensation molecule, the product is polymer and small molecule that eliminate by the reaction. Okay. The empirical formula of additional molecule is same, but the empirical formula of monomers times the amount of N. How many is repeated? And the condensation, because there is elimination of small molecules, the empirical formula will be different with the previous monomer, the constituent monomer. Okay, so in empirical formula is the smallest, is the simplest formula, right? The simplest formula, the empirical formula for in addition polymerization is the same with the monomers, but in condensation, remember, because there is removing of small unit, small molecule, it will be have different empirical formula. Usually there is a deduction. Okay, the MR is the multiple of MR of the monomers in addition polymerization, while in the condensation, it will be smaller than multiple of MR of monomers because there is removing of small molecules that has been mentioned before. Okay. Okay. First, this is the example of addition polymerization. If you have 18 acts as the monomer here. Okay. When you do the polymerization, the 18 will lose its double bond, but not losing any molecule of it, only losing the double bond and creating polyethylene. Okay, the process, this is a polymerization, and I will use this one to show the repeating unit. Okay, it should contain at least 2 carbon. Why it should be contain at least 2 carbon? Because remember, it should addition polymerization should made from a double bond molecule. Monomers should have double bond, so it should be at least have 2 carbon. So if I draw the repeating unit, this is the repeating unit. 2 carbon, right? At least. So if I simplify the structure, I will use it this one. And I will write it N. This is actually the reaction, the reactant. This is the product. So if I simplify this product, I can write it here. Yeah, this is called repeating unit. Why Michelle is not right just here and N? Remember, should made at least from 2 carbon because the monomer should have double bond. Okay, understand? It's actually plastic that you use generally. Yeah, PET. Okay, PE actually. PET is poly. I forget what it is. Okay, this is the practice for you. The first one is called polystyrene, styrofoam. That is the brand. Okay. If I ask you to show the repeating unit, how you can show the repeating unit of this one? So if I view, I will say the repeating one. This is repeating. This is repeating. So I can see here like this one. And this is the benzene. Benzene actually. The cyclic one. Okay. This is the repeating unit. So I can write it like this one in simplify one. Yeah, if you need to write the repeating unit, you can use this one. This is the simplified. Okay, for the repeating unit, just write this one, or you can use like this one. And. Okay, if you want simplify. Repeating unit, only this one. This is repeating unit. One more. This is repeating unit. If you want to make the simplified, you just write it here. That. Okay. How about the monomer? The monomer is this one. Remember, the monomer should have double bond. So therefore, the monomer. Why I not put N here? Because for the monomer is already complete, right? For carbon for HC. Okay, this is for the polystyrene A. Okay, other example. Okay, this is the polypropylene. Okay, if I ask you to draw the structure, the real structure of this one, actually it will be like this one. And you can add more here. And so on. You can add more of it. How about if I ask you to use, what is the monomer? This is the repeating unit, right? How about if I ask you to draw the monomer? Monomer of this one. Remember, always have double one. Okay. Ha, ha, ha. Sure, it's have 4 carbon each. Yeah, that is the monomer. Acrylamide. So if I want to make the polyacrylamide from this one, I will draw like this one. I will repeat drawing of this one. One. Why is not double bond anymore? Remember, in addition polymerization, you will remove the double bond. Okay, and creating new bonding here. Okay, the rest will be the same. And add more. Okay. I cannot draw it very nicely. Okay, this is it. This is C. Sorry. O and H2 and so on. If you want to add more, okay. How about if you should do it as repeating unit? So the repeating unit of this one, I will use other color, is this one. C, H, 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 C, O, and H2. This is the repeating unit. Okay. How about if you want to make simplify, you just put N here. Sorry. This is too large molecule actually. So you write it here. And yeah. This is actually the example of condensation by using polymerization by using condensation. So if you see here, the first one we will have amino acid. Amino acid, if we make it into polymer, it's called protein. All amino acid has the same structure. Here you can see it have amine group and it have carboxyl group, carboxylic acid in chemistry. Amine is an H and it have hydrogen and it have R. This R is various. This is the various one. The simplest one is hydrogen. You don't need to remember this one. When condensation happen, this one, the carboxylic group, the OH from carboxylic group will be removed and joined with it's in the amine group in the next amino acid. And then it will make water and then peptide bond in biology, or you can call it as amide bonding in chemistry. Okay, so this is the reaction actually. This can be various actually. So the monomer can be various in amino acid. This is how the condensation happen. Okay, because this is actually the it's called amide bond, not peptide. Yeah. So amide bond, you can see here is the amide bond. This is the form of the amide bond. This is C, this is another C. Okay, this is the amide bond. Remember, you have to identify the bond. Ester, amide, and ether usually. But for ether, you will rarely use it. Okay? Okay. For the condensation molecule, you need to search the specific bond first. So this one is amide. Yeah. So you can see this is amide. This is amide. Okay. This is amide bond. This is amide bond. Okay. Okay. This is the repeating unit. So you have to draw this one also. CH2 times 6. Actually, it's been CH2 until 6 times. And H and CO. CH2 4. It's mean CH4 until 4 times. CO. And this one strip. If it's repeating unit, just this one. This one strip for simplified diagram. And you put it N. How about the monomer? There is two monomers. There is two monomers. Actually, it can take from this one. This is addition molecule. So the original molecule should have another substance actually. From nylon, that is this one H. This one also H. This is N. I mean, big, sorry for my drawing, that is very messy. Okay, that is this one, the other molecule of this is the two monomer of nylons. So when actually condensation happen, this H and this Cl will be removed, okay, and creating new bonds. So therefore, actually, this one, sorry, my drawing is messy. This is N, CH2, 6, and it's now there is no new bonding here. CO, CH2, 4, CO, Cl. This is the condensation. And it will create H plus Cl plus HCl. Yeah, that. And this one will be repeated. Okay, that is for nylon. Because nylon has a lot of amide bond. It's can call as polyamide. Okay. Okay. I have another example for polyester. For yes, for you. That is polyester. Only is from PET that converted into polyester. So this is polyester. For this is the repeating unit of polyester. Polyester is made. Oh yeah. Sorry. This is already the repeating unit. So if you want to make it very long way like this one, you can draw it more and more. Up to you. Okay. I will only search for the it here as I am not unable to draw this one. So I will move to paint. Here actually the monomer of polyester of this one. So this is the carboxylic acid. This is the alcohol. Yeah. Ethane 1,2-diol because it have two alcohol. Okay. So actually what actually happened when this is react? This is actually what that happened that make the polyester condensation of polyester. So the esterification will be happen. So OH here and H here will be removed into H2O. And this one, COO, will make this one. And the rest of CH2OH is here. While this one is actually benzene, it's called benzene. But you have not yet learned about this one. Later you will learn it when you in another level. Okay, like this one. That is the condensation reaction. Okay. Okay. This is for the polyester. For the oni. Okay. The next one is glucose. This is the monomer. When a glucose react with other glucose, so I will move here also. Okay. This will make H2O, water. Okay, because this one is removed. This one is also removed. This will make join here. Yeah. This will make it into COC. That is ether. But you will not learn the ether too much. So I only will want to show you that this condensation. Or you can, if you want to see it more clearly, okay, this is condensation of glucose. In biology, we cannot call it ether bond, but glycosidic. But you don't need to remember it. I just want to show you this is H and this is OH. It will produce water, and this is will create bond, COC. It's called ether bond actually, but you will not learn it in chemistry actually too deep. I only want to show you that this also condensation, and that is about the last one, plastic. Plastic is actually synthetic polymer. All plastic is polymer. Usually it's made from fossil fuels. So that's why it's non-renewable and need to be recycled. There is several type of plastic depend on the recyclable of the plastic and depend on how the monomers. Yeah. So, for example, I said that Oni is made from PET before that convert into polyester. Yeah. So therefore, Oni is able to be recycled. So for this number, you only need to read it by yourself. It's not too important. This is only for your knowledge. Okay. Now, the problem is the disposal of the plastic. Usually, the plastic will be melted and used again to make the new product. In the case of Oni, no. In the case of Oni, the PET will be shredded, and then it will be depolymerized, and it will be repolymerized into other substance that is Oni, that is polyester. Okay, the plastic will be melt and used again to make new product in some case, and melt and crack into small molecule and create new product. Or if it cannot be reused or recycled, it will be dumped in a landfill, burn in incinerator. That energy from the combustion can be used for the electricity generator, but somehow this is also dangerous because it will produce toxic gas. That usually one of it's called dioxin, but it's not all it's dioxin, but it's really make a toxic gas. Okay, for PET it can convert back into its monomers, so it can be recycled and repolymerized, and also for PET can be repolymerized into another type of plastic like Oni, polyester. Okay, this is the process actually. This is the plastic sheet that like the beginning of the plastic that you want to recycle, or in the beginning of before it's creating a plastic bottle or something else. Okay, plastic has effect to the environment. If you just dispose it in landfill, it will be like this one. If it let it accumulate in the ocean, it can be trap the animal and also can be cooked by the animal. And also microplastic, one of it toxin again, can be swallowed by the animal and can be toxic for them. And also can reduce their fertility. It's very dangerous. And also the formation of toxic, if you burn it, it toxic gas. So how you can reduce the plastic? Use the biodegradable polymer. For now, there is plastic from cassava that easier to be break down by the environment by bacteria. When single plastic use like in Jakarta, you no cannot use that plastic bag, right? You only can use the tote bag that actually it's also a kind of plastic that called polyester, but it's not single use and etc. Okay, this is your homework later on. Thank you. That's all. Thank you. Save me by making me new polyester. Bye bye.